All right, we have another force example. This force example deals with finding individual forces. So example 3, an applied force of 170 newtons is used to accelerate an object to the right at a rate of 13 meters per second squared across a frictional surface. If the mass of the object is 8 kilograms, what is the force of friction acting on the box? So we start with noticing that there's an acceleration. So when we draw our force diagram, we should realize that it is unbalanced. So let's start with my force of gravity pulling down towards the center of the earth, being opposed by the normal force, which is the surface that's pushing back up. Now I have an applied force, and I do have a positive acceleration to the right, which means my applied force is going to be greater. Therefore, when I draw that, I'm going to have friction that's opposing, which is right here. Okay. I do know that my applied force is 170 newtons, so I'm going to put that value in. I don't know my force of friction, and I don't have any other values as of right now on my force diagram. So what I can do is I can take a look at what else I have, what other information I have. I do know the mass, and the mass is 8 kilograms, so I'm going to put it down here to organize my thoughts. I'll also put it in the middle just to help me out. Okay, I have my acceleration, and my acceleration is 13 meters per second, positive 13 meters per second squared, and that is to the right. And then I'm trying to find my force of friction. That's what they're asking me to find. But in order to do that, I need to know my net force before then. So we're going to need to find that first. So if I have my Newton's second law, I know that F net, my net force, equals mass times acceleration. Since I do have my mass and acceleration, I should be able to find my net force, and that will allow me to get my force of friction. So let's plug what we know into our equation. So I have my mass, which is 8 kilograms. I have my acceleration, which is 13 meters per second squared to the right. When I multiply those two together, the two magnitudes in my calculator, 13 times 8 gets me 104 newtons. And that also is to the right. So I now know my net force is 104 newtons to my right. Now, that means my entire system has a net force of 104 newtons. So that gives me information that I should be able to find my force of friction. So if I do this, I can set up a equation. If I know my force applied minus my force of friction needs to give me my net force. Okay, my force applied I know is 170 newtons. I don't know my force of friction, but I do know my net force based on my equation is 104 newtons. So if that's the case, I just need to solve for force of friction. If I subtract 104 from both sides, I should find that my force of friction is 66 newtons, and that is to the left. So if I put that back in my drawing, if I check this to make sure that I'm correct, again, I know my net force is 104. If I subtract, I know these two cancel out, so I'm subtracting my horizontal forces, 170 minus 66, which gives me my 104 newtons, and that's to the right, which gives me my net force, and I know I'm correct. So my answer here for force of friction is 66 newtons left.